Going to deal with we are supposed to solve some problems on CODs, which I have not done previously. So today I want to solve one 2 to 3 problems on COD, and apart from that, I want to deal with one more topic, that is ozone depletion, which I have not done. Probably I have done it. I felt one more time I need to speak on that particular thing. So today I want to do that thing. So, as we all know, just I'll I will just recollect what is a COD, then I'll go for solving the problem. So, the principle behind COD is nothing but it is the amount of oxygen in milligrams required to oxidize the organic and inorganic compounds present in 1 dm cube of wastewater using a strong oxidizing agent like K2Cr2O7 under aerobic condition. So we are going to take 1 liter of wastewater, and then we are subjecting it for the oxidation using a strong oxidizing agent in presence of acidic medium, and amount of oxygen required is measured in terms of milligrams. So it is measured by back titrating the amount of K2Cr2O7 which is not consumed in the titration. So this is the principle behind this particular method, is that a known amount of water is refluxed with a known excess acidified K2Cr2O7. So here acidified K2Cr2O7, in the sense we are going to take a potassium dichromate solution, and to that we are going to add H2SO4. We all know that K2Cr2O7, that is potassium dichromate, is going to be strong oxidizing agent in presence of acidic medium. Along with that, we are going to add small 1 gram of Ag2SO4, and we are going to add 1 gram of HgSO4. The purpose of adding Ag2SO4, it acts as a catalyst, whereas HgSO4 is going to act as a removal of interfering radicals. Then the K2Cr2O7, it oxidizes all the oxidizable impurities. So whichever is oxidizable means the organic load is easily oxidizable compared with the other things. So we are going to oxidize the organic load that is present in a wastewater with the help of this K2Cr2O7 in presence of H2SO4. Along with that, we are going to add silver sulfate, which is going to act as a catalyst, and along with that, we are going to add HgSO4, which removes the interfering radicals. That is, if there is any pyridine components are present in a wastewater, that will be removed by this HgSO4. Then the amount of unconsumed K2Cr2O7 is determined by titration with FAS. Once the oxidation is completed, then the entire setup is cooled to the room temperature. Then the solution is titrated against FAS solution. We all know that FAS is nothing but ferrous ammonium sulfate solution, and here the indicator used is Perion indicator. So the amount of K2Cr2O7 consumed corresponds to the COD of a sewage sample. So here we are going to do 2 titration. One is a back titration, another one is a blank titration. So this back titration is also called as the sample titration. So in case of a sample titration, what we are going to do is we are going to take a 25 ml of wastewater into a clean conical flask. To that, we are going to add 2 test tubes of 2N-H2SO4 solution, and then we are going to add 10 ml of, or pipette out 10 ml of K2Cr2O7 solution to the same conical flask, and then we are going to add 1 gram of HgSO4 and 1 gram of Ag2SO4. Then this is attached to a refluxed condenser. It is a glass device will be there through which we can circulate the water that will be fixed to the conical flask, and this entire set is heated, means conical flask with a reflux condenser, it is refluxed for 2 hours. Refluxed in the sense it is a continuous boiling. Since the condenser is going to be there at the top, it does not allow any vapors to escape. So that's why we are going to boil it for 2 hours. Once it is boiled, then it is cooled and it is titrated against FAS. That is unconsumed K2Cr2O7 is titrated against FAS using the ferrion as an indicator till the color of a solution changes from bluish green to reddish brown. So this titration, what is the this titration is called as a sample titration, and amount of FAS consumed is represented as A. Here it is A. It is represented as A. Then we are going for a blank titration. Blank titration in the sense here the same procedure is going to be repeated with the help of a distilled water. We are not going to take a wastewater. We are going to take a distilled water. Then we are adding two test tubes of 2NH2SO4. We are going to add 10 ml of K2Cr2O7. We are going to add 1 gram of HgSO4. We are going to add 1 gram of Ag2SO4, and we are connecting it to the condenser and we are refluxing it for 2 hours. Once it is refluxed for 2 hours, then in that case, then after that again it is cooled and then it is titrated against a FAS. So this titration we call as a blank titration, and the amount of FAS consumed is written as B, volume B. Now we are going for the record of observations and calculation. So the volume of water sample taken is V1 ml. So V1 cm cube, V1 dm cube of solution we are going to taking. Then the volume of standard FAS used in the sample titration is equal to A cm cube. Then volume of FAS used in the blank titration is equal to B cm cube. Then the normality of FAS is equal to N. Then amount of K2Cr2O7 consumed in satisfying the COD in terms of FAS is nothing but the difference between a blank titration and a sample titration. So that we are going to write it. We know the formula, that is N1V1 is equal to N2V2. If you know the normality and volume of 1, it is possible to find out the normality and volume of the it is possible to find the unknown factor that is known to us. It is known to us. So that's why we are going to use this one. now, now the same thing we are going to substitute here. That is N1. N1 is nothing but it is a normality of the the volume of V1 is nothing but it's a volume of water what we have taken. N1 we are going to take it as the normality of a COD of a sample. So that we are going to take it as a N1. Then N is nothing but the normality of a FAS. B minus A is nothing but the difference in the volume of consumed during the the blank solution and the back solution. Then this is divided by the volume what we have taken. Then it is hello. ಏನ್ರಿ ಒಂದು ನಿಮಿಷ just a minute, I'll be back. the volume of water sample what we have taken using this equation, that is N1V1 is equal to N2V2. The same thing here we are going to modify it as N1 into V is equal to N into V minus A. Sir, WhatsApp check matter, please. The volume of N1V1 is equal to N into B minus A. So the normality of COD of a sample is given by N into B minus A. Here minus sign is missing, but a minus sign will come here, and divided by the volume. Therefore, the COD of the sample is equal to N into B minus A divided by V into 8. Here we are going to take 8. The purpose of taking the 8 is the equivalent weight of oxygen. So that's why we are going to take that one. So then it will be multiplied. At that time, the volume, whatever the amount what we are getting, the COD is in terms of grams per dm cube. But we want it in terms of a mg per dm cube. That's why what we are going to do is N into X B minus A divided by V into 8 into 1000 mg per dm cube. So in this way, we are going to use this equation to find out the the COD of a wastewater by by this method. So the importance is it is used to measure the pollution strength of a pollutional strength of any wastewater. Second one is how to manage the treatment plants, whether the load is going to be more or less, that will be understood by with the help of this one. And apart from that, it is a very quick, within 2 to 3 hours this entire experiment will be get completed. That's why it's going to be more useful compared with BOD. So this is the equation which we are supposed to keep it in our memory, that is COD of a sample is equal to N into X N into B minus A divided by V into 8 into 1000. If we keep this equation in our memory, then it is easy to solve the problems. So here the required factors are, one is the normality of FAS, and another one is volume of FAS consumed in the sample titration, FAS consumed in case of the blank titration. Then if you know the volume of a wastewater what is taken, if these 3 to 4 things are known to you people, then it is possible to calculate the COD of a sample. So now I'm going to show you the how to solve the problems using this one. So see here, I've taken about 2 to 3 examples, and based on that thing, I'm going to solve this. So the first one, in a COD test, that is 28.1 and 14.0 cm cube of 0.5 N FAS solutions were required for the blank and sample titration respectively. So these are the volumes consumed in case of the blank as well as the sample titration. The volume of test sample used is 25 ml, and calculate the COD of the sample. And just a minute, I'll be back. So here they have given you A, B, and normality they have given you, and at the same time they have told you about the B. Substitute these values into the given equation and you will get it. So first you are supposed to write the entire thing properly. Data has to be written properly. So the volume of 0.1 FAS required to react with. So they have, here there is a mistake in this problem. Just you need to change this 0.1 into 0.05 N. So normality of FAS is 0.05. then required to react with unconsumed. Then then you substitute A and B. Once A and B is filled, then here B is 28.1, whereas A is equal to 14.1. The difference is going to be 14.1 ml. Then substitute the values. So once you substitute, here is one more mistake done by me, that is 0.05 it should be, but I have made it as a 0.5. So correct it and you calculate that thing and you will get the proper answer. Just let me calculate one more time so that I can do it properly. So here in this case, it is going to be 0.05, 0.05 into 14.1 divided by 25 ml divided by 25. It's going to come around 0.0282. That has to be multiplied with 8. Then that has to be multiplied with 1000. So if you do that thing, you are going to get the answer as 225.6 grams, 6 mg per dm cube. So the calculation wise, this is correct. Only in case of representation of this normality is concerned, this is done, a little bit of mistake is observed in this particular sum. So rest all, that is, if you multiply this entire thing, you are going to get the volume like this only. Then further, after multiplying it with 1000, we are going to get 225.6. Similarly, one more is there. Just if you have the pen and a paper, just solve this one and check whether you will get it as 600 mg or no. So the first thing is the problem reads out to be like this: 20 ml of sewage sample for a COD is reacted with 25 ml of K2Cr2O7 solution, and unreacted K2Cr2O7 requires 9 ml of N by 4 FAS solution. Under a similar condition, in a blank titration, the 15 blank titration, 15 ml of FAS is used up. Calculate the COD of a sample. So first thing is volume of a sample taken. It is 20 ml. Then volume of FAS. So first thing is normality we are supposed to see. N by 4 in the sense normality is going to be 0.25. Normality of FAS is equal to 0.25. Then the volume of FAS consumed, unconsumed, that is FAS consumed in case of the sample titration is 9 ml. Then a volume of FAS consumed in case of blank titration is 15 ml. Then amount of FAS consumed in terms of a COD is equal to difference between the blank titration and the sample titration, that is 15 minus 9, that is equal to 6 ml. Then using the formula N1V1 is equal to N2V2, substitute the values. N1 is not known to us, whereas V1 is equal to 20 ml, and the normality of FAS is equal to 0.25, and volume of FAS is equal to 6 ml. Therefore, that time the calculation is going to be then 0.25 into, just to do it and you will get the answer or not, just check it. 0.25 divided by 20. You are going to get, if you just simplify this one, you are going to get it as 0.075. Then multiply it with 8. Then again multiply it with 1000. Then in that case, you are going to get the answer as 600 mg per liter. So this type of questions, these are the examples which are appeared in the question paper. The same problems I have taken and I have solved this one. So these are the problems which are going to come in your in your semester exam. So each question, each problem is going to carry about 6 marks, 5 to 6 marks. It's going to be there. Each step means even if the writing of a data is also going to carry you a marks, and substitution. And if you complete this entire thing, it will give you 5 to 6 marks without deducting anything. They will give you the marks. So that's why it is a simple multiplication, my subtraction, multiplication, and division reaction calculation is there. So solve some more problems of this type, and automatically you will get a confidence to do that thing. So if you know the volume of volume of FAS consumed in the sample, volume of FAS consumed in the blank titration, then volume of the wastewater taken, and the normality of FAS. If you know these three to four things, then it is possible to calculate the COD of the sample. So one more is there. Just you, if you are having a pen and pencil right now with you people, just go for this one. One more is there. Just note this one. So 25 cm cube of sewage water is reacted with 10 ml of or 10 cm cube of 0.2 N K2Cr2O7 in a concentrated H2SO4 medium. The unreacted K2Cr2O7 needed 6.1 cm cube of 0.1 FAS and 10 ml. Again the same thing they have repeated. When titrated under same condition, it required 28.2 cm cube of FAS. So 28.2 is B, whereas 6.1 is A. Then normality of FAS, they have given it as a 0.1, and the volume of sewage water they have used is 25. Right, the same thing. The volume of FAS consumed in the sample titration is equal to 6.1. Volume of FAS consumed in case of blank titration is equal to 28.2. Then the COD in terms of FAS is equal to 28.2 minus 6.1, which is equal to 22.1. The normality of FAS they have written as 0.1. So write that one. So then substitute the value. First write the formula of N1V1 is equal to N2V2. Then substitute what is V1. V1 is equal to 25 ml, whereas the normality of FAS is equal to 1.1 into 22.1 is the volume of FAS, COD in terms of FAS. Then simplify it. At that time it is going to come as, that is 0.1 into 22.1 divided by 25. It's going to come as 0.0884. Then it has to be multiplied with 8. Then it has to be multiplied with 1000. So then we are going to get it as 707.2 mg per dm cube. So this is the volume, or this is the COD of this waste water. So in this way, we are going to calculate the COD of a given sample of water. water. So usually it is asked in the examination. Instead, it is better if they will ask it in the examination. It's going to be very nice. Instead of asking the theory, if they will ask the problems, it is going to be less time consuming and gives you more marks. So that's why please solve repeatedly all such a problems, and it will help you people. Now I'm going for the one more important topic that is that I was supposed to deal is this one, depletion of ozone. Just I want to remind one more time, then I'll come back, I'll complete this one. Okay, I'll share to that one, and then we'll talk about that particular thing. I hope the COD problems are clear for you people. Okay, now I'm going for the ozone layer. See, in the previous, in one of the exams, they have asked about the write a note on ozone depletion. So they have asked for 5 marks question. So that's why I've taken this as a separate thing. Ozone layer is nothing but ozone layer is a layer which is present in a stratosphere, and it has a capacity to absorb the harmful ultraviolet radiations from the sunlight. It protects the various life forms on the earth. It protects from the UV radiation. Ozone is the form, it is one of the form of oxygen, and it is the molecular. In case of oxygen, we are going to have the 2 atoms of oxygen, whereas in case of ozone, we are going to have 3 atoms of oxygen which are going to be present. That's why we call this one as a ozone, and it is mainly present in a stratosphere. So it absorbs the short wavelengths of ultraviolet radiation. Due to that, the reaction is going to take place continuously. Initially, the molecular oxygen that is present in the atmosphere, once it comes in contact with ultraviolet rays, it splits, it decomposes to give the 2 oxygen atoms. These atomic oxygens again combine with a molecular oxygen with the liberation of energy. That is one more intermediating third party is necessary to absorb the heat liberated. So by combining these two, that is atomic oxygen and a molecular oxygen, we are going to get the oxygen, and along with that we are going to get an activated compound that is going to be present in the atmosphere. Then ozone is formed, distribute itself into the stratosphere and absorbs the harmful radiations continuously, and the reaction keeps on occurring. By absorbing this ultraviolet radiations, the molecular oxygen is going to split as an atomic oxygen, and this atomic oxygen again it combines with one another, and this process of formation and decomposition keeps on occurring in the ozone layer. So this keeps on occurring, and due to that the layer keeps on forming. This reaction is imbalanced, or this is going to be broken with the presence of a chlorine or a bromine. Instead of this oxygen molecules, if there are excess number of chlorine atoms or the bromine atoms are existing in the nature, in that case they will start to get involved in the reaction. So once they start to get involved in the reactions, automatically instead of a formation of a ozone, the depletion of the ozone layer keeps on taking place. So these are the two activities that decomposes or that destroys the ozone layer. Is one is the spray cans what we are using, and the second one is the refrigerants, the refrigerant gases that are going to be used, and the second one is one more is that the supersonic jets which are flying in the sky, they are also contributing for the depletion of ozone layer. So apart from that, one more thing, the detonation of nuclear weapons. The nuclear weapons what we are using, that will also destroy this ozone layer. The freons in the sense, the freon 11 is nothing but the trichloro and fluoromethane compounds. Trichloromonofluoromethane, that is, instead of a methane, the hydrogen atoms are going to be replaced by chlorine and a fluorine. Then in that case, the compound is going to be trichloromonofluoromethane is going to form, and this is going to contribute for this chlorine as well as for the bromine. So we have to avoid these freons, and freon 11 and freon 12. Freon 11 and freon 12 are going to be the harm causing gases that we are using in our day-to-day life. So this freon 1,2, it is used in case of refrigerators, it is used in case of air conditions, even it is used in case of freezers. So there we are going to use, these are going to be released, and these are going to take the reactions. So the reactions, the effects of freons on the ozone layer is as follows. So the photodissociation of a freon is going to take place. At that time, the nascent chlorine atom is going to be released. This nascent chlorine atom, it's going to react with the ozone, and it will form the chlorooxy compound. chloroxy compound is get deflated, and only the molecular oxygen is going to present in the atmosphere. So this will lead to the formation of the formation of the molecular oxygen instead of ozone. Due to that, the depletion of a layer is going to occur. And apart from that, we said that the supersonic jets are affecting. The supersonic jets are going to emit the oxides of nitrogen into the atmosphere. These are going to combine with a ozone molecule, and that will lead to the formation of one more that will lead to the formation of a molecular oxygen. This molecular oxygen further is converted into an atomic oxygen. Due to that, the formation of the ozone is prevented. The formation of ozone is prevented automatically. The thickness of a layer keeps on degrading. So it has to, every time the formation of ozone keeps on taking place, but instead of that, the other things, other activities are occurring. Due to that, the thinning of ozone layer is occurring. Next is the due to the effect. So what are the effects of this ozone layer? So it penetrates into the atmosphere. So these are the ultraviolet rays which come in contact with the skin. It burns. Sometimes it will lead to the formation of skin cancer. Sometimes it kills the puma and flora that is going to exist in the atmosphere. And it also affects the photosynthesis processes. It causes the mutation in the sense the repeated formation of cells, the mutation that is mainly takes place in case of cancer cells. So more exposure to the ultraviolet radiations that will lead to the formation of cancer. So this is how the ozone depletion of ozone is affecting we people. Apart from that, the degradation of paints, plastics, and other polymer material will also result in the economic loss. That is fading of a color, outermost layer, that is the paint what we apply for our homes or any industries, that will be get decolorized because of the exposure to the ultraviolet radiations. So these are the effects that are going to take place due to the depletion of ozone layer. Usually, this ozone depletion is going to be asked in the examination for 5 to 6 marks. 5 marks, not 6 months. Most of the time, it is asked for 5 marks. So that's why you need to practice with the reactions. You need to understand. See, these reactions are all almost photochemical reactions. Photochemical reaction in the sense the energy is absorbed from the photons, and that will lead to the formation of a molecular oxygen and atomic oxygen. And at the same time, even the same atomic the photonic photo energy is used for the combination of atomic oxygen and molecular oxygen. So these are the reactions which we need to supposed to involve, and the compounds, that is ferrion 11 and ferrion 12, that is trichloro monofluoromethane and difluoromethane. These are the two compounds which are used in case of the air conditions, refrigerators, that are going to cause all these reactions. You should be able to. There are two reasons for the depletion of ozone. One is the usage of this ferrion 11 and ferrion 12, and second one is the high flying supersonic jets that emit the or nitric oxide. This nitric oxide has the capacity to combine with the oxygen, and this will combine with the ozone with the formation of a molecular oxygen, and that will lead to the formation of the molecular oxygen. Then apart this nitric oxide is also going to combine with the molecular oxygen, which will lead to the formation of a nascent oxygen. So these are the reactions which you need to practice a bit, and if you understand it, these are not that much complicated reactions, that you can use it in your write up. So this is about the entire chapter of fourth module. It is a general type of a module, but it was previously in the sense, if you are in a lower classes, the expectations are going to be less, but when you are studying in the graduation, then the details how you give, that will carry you the more number of marks. No doubt these are general topics, but you need to be specific in answering how the reactions are going to take place, and all that thing you need to be particular. that will help you to get the proper answer. I hope with this I'm going to stop today's class. If you have any doubts, please send me the message or call me anytime. I'll be there with you people. So from tomorrow, I'm going to start the nanotechnology. After nano, I'm going for the instrumental analysis. So already you have done the instrumental, some of the instrumental experiments. Based on that thing, the theory will be discussed and how it will be performed. All that thing again, I'm going to discuss in the online class only. So any doubts if you are having, please send me the messages and give me the feedback of this one. Uh, thank you. Thank you, everyone.